The abacus, a simple yet powerful calculating tool, has played a pivotal role in the history of mathematics. For millennia, it has empowered merchants, scholars, and mathematicians to perform complex calculations. Its enduring legacy is a testament to human ingenuity. The abacus has transcended time and culture. It has left its mark on civilizations across the globe. The abacus is a testament to the power of human invention. It predates modern calculators and computers, yet it remains a relevant and valuable tool. Its story is a fascinating journey through the history of mathematics and technology. The origins of the abacus can be traced back to ancient civilizations. These early societies, including the Sumerians, Egyptians, and Chinese, were among the first to develop methods for counting and recording transactions. Evidence suggests that early forms of counting boards were used as far back as 3000 BCE. These boards were simple yet effective tools that allowed people to keep track of numbers and perform basic arithmetic. These early devices laid the foundation for the development of the abacus. They were crucial in the evolution of the mathematical thought and the ability to perform calculations more efficiently. They highlight the human desire to find efficient ways to calculate. In bustling marketplaces and trade centers, the need for accurate and quick calculations was paramount, driving innovation in counting tools. One of the earliest known forms of the abacus is the Mesopotamian counting board. This device was a significant advancement in the history of mathematics and commerce. This device utilized a system of lines drawn in sand or on clay tablets. These lines served as guides for placing pebbles or tokens which represented different numerical values. Pebbles or tokens moved along these lines to represent numbers. This method allowed for more complex calculations than previous counting methods, such as tally marks or knots on strings. The Mesopotamian counting board was a significant step towards the development of more sophisticated calculating tools. It paved the way for future innovations, including the Roman abacus and the Chinese swanpan, which would further revolutionize the way humans performed calculations. Mesopotamia, the cradle of civilization, played a vital role in the development of the abacus. The ancient Mesopotamians were skilled mathematicians and astronomers. They developed a sexagesimal number system. This system, based on the number 60, is still used today for measuring time and angles. To aid their calculations, the Mesopotamians developed a counting board. This board consisted of a flat surface. It had lines drawn on it to represent different place values. Small stones or tokens were moved along these lines. This allowed them to perform addition, subtraction, multiplication, and division. The ancient Egyptians also developed their own versions of counting boards. These boards, often made of wood or stone, used pebbles or beads as counters. Egyptian counting boards were used for a variety of purposes. This included keeping track of trade, surveying land, and calculating taxes. The use of counting boards in ancient Egypt highlights the importance of mathematics in their society. These tools allowed the Egyptians to manage their vast empire. They also made significant advancements in fields such as astronomy and engineering. Section 5. Ancient Rome, calculating on the move. In the bustling markets and busy streets of ancient Rome, the need for quick and accurate calculations was paramount. The Roman abacus, known as the abacus calculi or calculus, was a portable counting board. This ingenious device was a testament to Roman innovation and practicality. It consisted of a metal plate with grooves. These grooves were meticulously designed to hold beads or counters in place, allowing for precise calculations. Beads or counters could be moved along these grooves to perform calculations. Each movement of a bead represented a numerical value, making it possible to add, subtract, multiply, and divide with ease. The Roman abacus was a practical tool. Its simplicity and effectiveness made it indispensable in various aspects of Roman life. It was used by merchants, engineers, and soldiers. Merchants relied on it for keeping track of transactions, engineers for precise measurements, and soldiers for logistical calculations. The portability of the Roman abacus made it an essential tool for a society constantly on the move. Whether traveling along the vast network of Roman roads or setting up camp, the abacus was always within reach. Roman engineers used it for surveying and construction. The accuracy provided by the abacus was crucial in building the architectural marvels that still stand today. Merchants used it for trade and commerce. In the lively markets, the abacus ensured fair transactions and helped maintain economic stability. Its influence can be seen in the development of later calculating devices. The principles of the Roman abacus laid the groundwork for future innovations in mathematics and computing, bridging the ancient and modern worlds. Section 6, the abacus in Asia, a rich history of innovation. The abacus reached new heights of sophistication in Asia. The Chinese swanpan and the Japanese soroban are two notable examples of how the abacus evolved. These abacuses featured a divided frame with beads. This allowed for more efficient calculations. The abacus became an integral part of Asian cultures. It was used in education, commerce, and everyday life. The development of the swanpan and the soroban highlights the ingenuity of Asian mathematicians. It also solidified the abacus's place as a powerful calculating tool. Section 7. The Chinese swanpan, a mathematical masterpiece. The Chinese swanpan, which emerged around the 13th century, is a rectangular frame. It is divided into two decks. The upper deck has 2 beads per rod. The lower deck has 5 beads per rod. This unique design allows for efficient representation of numbers. It also facilitates complex calculations. The swanpan was widely used in China for centuries. It was an essential tool for merchants, accountants, and mathematicians. Its use spread to neighboring countries. This includes Korea, Japan, and Vietnam. Section 8. The Japanese soroban refining efficiency. The Japanese soroban, a close relative of the Chinese swanpan, emerged in the 14th century. It features a simpler design than the swanpan. It has 1 bead on the upper deck and 4 beads on the lower deck per rod. This streamlined design allows for even faster calculations. The soroban became an integral part of Japanese education. Children learn to use it from a young age. It is still taught in schools today. This ensures that the tradition of abacus calculation continues to thrive. Section 9. The abacus in education, a tool for young minds. The abacus has been an invaluable tool for teaching mathematics for centuries. Its concrete nature makes abstract mathematical concepts more accessible to young learners. Children can visualize numbers and operations. This helps them develop a strong foundation in arithmetic. Using an abacus can enhance problem-solving skills, improve memory, and boost confidence in math. Its continued use in education is a testament to its effectiveness as a learning tool. Section 10. From abacus to computer, a legacy of calculation. The abacus may seem like a relic of the past in our digital age. However, its legacy lives on in modern computing. The abacus laid the groundwork for the development of calculating machines. This ultimately led to the computers we use today. The principles of place value and bead manipulation, evident in the abacus, influenced the design of early computers. The abacus's impact on computing reminds us that even ancient technologies can inspire future innovations. Section 11. Conclusion. The abacus, a timeless tool. The abacus, from its humble beginnings as a simple counting board used by merchants and traders to its refined forms in the Chinese swanpan and the Japanese soroban, has left an indelible mark on human history. It has been a crucial tool in the development of commerce, education, and science. Its enduring legacy is a testament to the power of human ingenuity and the quest for knowledge. The abacus shows our desire to find elegant solutions to complex problems, demonstrating the human capacity for innovation. Even today, the abacus continues to be used in various parts of the world. It is a valuable tool for teaching mathematical concepts, enhancing cognitive skills, and fostering an appreciation for the beauty of mathematics. Its story is a reminder that even in our technological age, where computers and calculators dominate, the simplest tools can still hold immense value and relevance. The abacus bridges the gap between the ancient and the modern, showing that traditional methods can coexist with contemporary technology. Across different cultures, the abacus has been adapted and used, reflecting the universal need for efficient calculation methods. It has also found its place in art, literature, and cultural artifacts, symbolizing the intersection of practicality and creativity. In modern classrooms, the abacus is not just a tool for arithmetic, but a means to develop logical thinking and problem-solving skills. Workshops and competitions centered around the abacus continue to inspire and engage people of all ages, keeping the tradition alive. Museums and educational exhibits showcase the abacus, highlighting its historical significance and ongoing relevance. Innovative uses of the abacus in conjunction with digital tools demonstrate that this ancient device still has much to offer in our rapidly evolving world. Whether in daily life or professional settings, the abacus remains a symbol of human ingenuity and the timeless quest for knowledge and efficiency.